So everybody do number one. Let's see here. Show me what it means to write x is negative. How do you write x is negative? All right, so you should have written x is less than 0. Okay? If you didn't write that, then it's wrong. Number two, the quotient of P and Q, and Q is at most 7. Quotient of P and Q is at most 7. Done? Quotient means take the first divided by the second. At most means it can't be greater than, so it means less than, but it can be the actual number. So less than or equal to 7 is the answer. Awesome. Number 3. Oh, let's do this. Absolute value of negative 3 minus 4. Okay, you should have said the absolute value of negative 7, which is 7. Number 4, let's do the absolute value of negative 11 plus 1. And you should have said that's the absolute value of negative 10, which is 10. If you said 12, then count it wrong. You got to do what's on the inside first. And number 5, the distance from A to B, if A and B respectively are 3 and negative 5. So, the distance between two numbers is like finding the range. Doesn't matter what order because you're going to do the absolute value. 3 minus a negative 5 is the same thing as 3 plus 5, which is the same thing as the absolute value of 8, which is 8. Just subtract the two numbers and take the absolute value. All right, so let's just say this was the quiz. That's half the quiz so far. Who has gotten all of them correct? Okay. All right, next slide. Number 6. Here we go. Let's see here. 1/2 x to the 4th times 16 x to the 5th. Simplify that, please. so since there aren't any addition or subtraction signs, and there aren't any exponents on the outside of the parentheses, we can just multiply everything together. So 1/2 times 16 times x to the 4th times x to the 5th. So that's 8x to the 9th. All right, next. Let's go number 7. 3y cubed, and that's going to be times 2y squared all over y to the 4th cubed. I don't need this parentheses over here. That times 5y cubed raised to the 0 power. I'll pause the video and check what you're doing. All right, so first of all, that's going to be 1. So it's not even necessary at this point. Second of all, I want to make sure that we take care of these outside exponents, because you can't multiply until you take care of those. All right, so we're going to distribute the exponents to the other exponents. Don't forget the 2 has an exponent on it. All right, so we still have 3y cubed. But now this becomes 2 squared y to the 4th and y to the 7th on the bottom. Now again, there's no addition and subtraction signs, so we can put everything together. 3 times 2 squared times y cubed times y to the 4th all over y to the 7th. 2 squared is 4, 3 times 4 is 12. On the top we have y to the 7th, on the bottom we have y to the 7th. Those reduce to 1. 12 is the answer. Who got it right? All right. Here, I'll pause this. Yeah, I'm sorry, I did that wrong. So this should be y to the 12th on the bottom. And if that's the case, then you're going to get 12 over y to the 5th. Okay, now who got it right? Sorry. Are we ready to go on? Nope, not yet. Okay, number 8. Hopefully we're doing better. Number 8. Let's have you do something like... where are they at? All right, let's just do this one here. -2 r squared s to the 5th power times 3r to the -1 s cubed, all of that raised to the 2nd power. All right, so I'll pause the video and give you a chance. All right, we're going to start. Again, let's distribute the 5 and the 2 through to every exponent. Cannot express that enough. Make sure you're doing that. Let's rewrite the problem. So we get a -2 to the 5th. Again, that will remain negative because it's an odd exponent. R to the 10th and s to the 5th. And that's times 3 to the 2nd, r to the -2, and s to the 6th. So -2 to the 5th is -32. 3 squared is 9. So we're going to have to figure those out. We have r to the 10th and r to the -2. You add those together, you get r to the 8th. And s to the 5th and s to the 6th gives you s to the 11th. All right, so the r and s are done, but now you take 9 times 32. So what you should do that in your head. 9 times 32, here's how you should do it. 9 times 30 plus 2. So in your head you have 270 and 18, that's 288. You can do that in your head. But on a test you can check it to make sure on a calculator. So you use these calculators up here on the test. All right, negative 288 r to the 8th, s to the 11th. Who got it right? All right, good. All right, going on. We got to keep moving. Number 9. All right, let's choose one of these other ones. 4 plus y, 4 plus x, all of that raised to the 3/2. Write it using radicals, please. You should notice that that's a improper fraction on the base. So what that means is 2 goes into 3 one time, right? So that base gets moved out from the radical with an exponent of 1. So the base is 4 plus x. And the exponent on that base would be 1. And then you have the square root of the remainder, which is 4 plus x, and the remainder is 1 as well. So those exponents are 1s. If you remember, x to the 3/2, 2 goes into 3 one time, so there's an x to the first on the outside and an x to the first on the inside. There's a remainder of a 1 on the inside. How many times does the root go into the exponent? That's the exponent of what goes on the outside. And the remainder is the exponent of what goes on the inside. So that would be the correct answer. I mean, if you think about it, if I said, what's the square root of 4 plus x quantity squared, what would you say? Wouldn't you say 4 plus x? Because the square root of a square? Well, you at least have a square in the 3/2. Okay? All right. So let's go on. Last one. We're running out of time here. Number 10. Here we go. 4th root of x to the 7th, y to the 12th, all over 125x. Again, I'll stop the video and wait. Okay, all right. Let's, you could simplify the x's inside first if you wanted to. That's what I would do. Did anybody do that first? 1 person? 2 people? 3? All right, we'll go ahead and do that then. All right, so the 4th root of, that'll be this x here cancels with one of those, leaving 6 on the top. So x to the 6th, y to the 12th, all over 125. All right, so now what you got to do is rationalize the denominator. You could simplify first if you wanted to. I think it's easier to simplify first. Did anybody simplify first? So you guys just rationalized first? What's the 4th root of 125? There isn't one, right? There's not an even one. So if we take this, let's just do this. The 4th root of x to the 6th and y to the 12th. The bottom is the 4th root of 125. So let's break that apart. The 4th root of 5 and what? 5 times what? Is 125. 25, right? Okay, so can we break that down? 4th root of 5 and the 4th root of 5 and 5, right? Do you have 4? Oops, 4. Do you have 4 of those? No. So does it break down? No. But you have to check these things as you're going through, make sure it's done. So what you're going to do here is you're going to have to just rationalize the way it is. So you have 125 to the 1/4. So you need to multiply by 125 to the 3/4. So I'm going to write it as a radical on the top here. So on the bottom, you're going to have 125. The radical's now gone. And on the top, you have the fourth root of 125 cubed, x to the 6th, y to the 12th. And you would be done, except these exponents are bigger than your root. So how many times does 4 go into 6? Once. So an x to the first is on the outside. How many are left over? How many times does 4 go into 12? 3. So you should have a y cubed out here. All right. At this point, you need to figure out what 125 cubed is. 125 times 125 times 125. Okay. We're going to leave it like this. Okay. So x, y cubed, because we're out of time. And that would be 125 cubed, x squared, all over 125. All right. All right. 71 is x to the 4th. Oh, no, this is... all right, let's do this. We're going to run out of time. The fourth root of 5x to the 8th and y cubed all over 27x squared. Now, the rules are you want to simplify and rationalize the denominator. So this looks ugly. It is ugly. But in reality, you need to know just a couple things. All radicals can be broken apart if there aren't any addition subtraction signs. Just always be ready. If there's addition subtraction signs, you can't apply a lot of these rules. But if it's all division and multiplication, you can separate everything. I could do the fourth root of 5. I can do the fourth root of x to the 8th. And you could just keep going, okay? And that would be okay. Absolutely okay to do that if you want it. What I would do first is look inside the radical and notice that I can reduce that. Okay? You can do anything at any time as long as certain rules have been applied. So what I have is the fourth root of 5x to the 6th y cubed all over 27. All right. Now let's apply the root. And so those of you who weren't here yesterday, I can't take the fourth root of 5. I can take the fourth root of x to the 6th. Okay? So what you do is you divide these numbers. 6 divided by 4. That's 1 2/4, right? Okay. So the mixed number is what you bring out, or answer this question. So let me rewrite this here. That's 5. Got y cubed here. Leave a little spot in there. All right. The x to the 4th. So the fourth root of x to the 6th. Let me ask you. How many times does 4 go into 6? 1. That is the outside exponent on the x that you're taking out. So if the exponent's bigger than the root, you can take one of those variables out. How many? In this case, you said 1. So the outside exponent's 1. Your remainder is what goes there. What's the remainder? 2. 4 goes into 6 one time with a remainder of 2. All right? So real quickly, again, let's do the fourth root of x to the 21st. How many times does 4 go into 21?
It's 27.
This is different. This is a separate problem. How many times does 4 go into 21? 5 times. That means that's the outside exponent. How many? What's your remainder? 1. X to the first is on the inside. If the inside exponent is bigger than the root, you need to take one of those bases out. Now, the y to the 3rd, that's not bigger than the 4, right? So you can't take out a y. And there's nothing else you can do. So now we've simplified by taking as many things out as possible. So let's just draw a line here. So we're taking out, where's it at? An x to the first, and there's an x to the first on the inside. 4 goes into 6 one time with a remainder of a 2, sorry. Good thing I went back through it.
What I said.
Yeah. Okay, so stop. I need to make sure you guys who weren't here at least understood what I've said. Should we do another couple simple examples? Everybody needs to be able to do this. Okay, let's do a couple simple examples here. So again, you can break all these apart. Let's do the third root of 81. Sorry, not 81. Let's do it exponent here. X to the 29th power. Okay? So, is the exponent bigger than the root? Yes or no?
Yeah.
Okay, so then you can take a base out. The question is, what's the exponent going to be?
X9.
So 3 goes into 29 how many times?
9.
9 times? That is what goes out in front. What's left over? 2, right? So that's what that would simplify into. All right. We can spend time doing this, though, the rest of the time. You still can go back and look at the simple review problems and some of these, okay? That would be your answer then, by the way, if I gave you that. But what they're doing is they're sticking these inside bigger problems. But do one thing at a time. One thing at a time, and just keep cutting away at it until you're done. Now, technically, you're done at this point. There's nothing left to simplify. Except it says you have to rationalize your denominator. That means you can't have radicals. All right, so those of you who weren't here, real quickly, if I said 2 over the square root of 3, in algebra 1 and algebra 2, you would multiply by square root of 3 over square root of 3. Does that look familiar? Because your denominator then would be what? Well, I hope you know, because you were here yesterday. Right? The square root of 9, which is 3, without the radical. And then on top, you have 2 square root of 3. All right, the reason this works, and the reason what you've been working on is fractional exponents. Look at the denominators there. So 2 over 3 to the 1/2. Isn't that 1/2, the square root of 3? Isn't that what the square root is? Right? That's a 2, and that's a 1. So that's 3 to the 1/2. So if we multiply by 3 to the 1/2 over 3 to the 1/2, which is, again, the exact same thing as what's above it. What do you do with your exponents when you multiply like bases? What do you do with them? Add them. Okay, so what? 3 to the 1/2 times 3 to the 1/2. What do you get? What's 1/2 plus 1/2? 1. That means you have no more radical in the denominator. That's why that works when you do this. Now the problem is, look at the problem we have. We have the 4th root of 27. So it's in the denominator. So let's make that a fractional exponent. That's 27 to the 1/4. Are you with me so far? Okay, so this is in my denominator. So I'm going to multiply by something, the same base, on the top and the bottom. But what does my exponent have to be for those to add up to 1? What do you add to 1/4 to get 1?
3/4.
3/4? Right? 1/4 plus 3/4 is 1, right? That's what you're really doing. And all these, the last few years you've been doing these things. That's what's happening. But you've only been doing square roots. So now you have to actually put them as fractional exponents. Okay? And what do you get? On the bottom, you're just going to get 27. Right? 27 to the first power. That's what you wanted. Are we good, or did I do something wrong? Good? Okay. All right, now what's on top then? Let me erase it. Let me get rid of a few things here. All right. So on the top, you have x and the fourth root of 5x squared y cubed all over 27 to the 1/4 times 27 to the 3/4 over 27 to the 3/4. All right, so that's what that says. That's where we're at. And you know now that the bottom is 27. All right, so again, just writing it out, 5x squared y cubed. And this will be the fourth root of 27 cubed. And tomorrow, the final answer should be x fourth root of 27 cubed times 5 times x squared times y cubed, all over 27. There's nothing else you can do with that unless you put those numbers together and use your calculator. Okay? These are complex problems. Next problem, real quickly. 77. Oh. All right. 77. Fifth root. I'll put this out in the next couple hours on Google Classroom for you. And you also have the fifth root of 4x to the fourth y squared. Whoops. Ugh. All right, let's treat both of these separately and then put them together. Can you simplify anything in the first one? Can't take the fifth root of 8. You can't, and all those exponents are smaller than 5. So technically speaking, that is simplified. What about the next one? Can you do anything with those? No. Are there any addition and subtraction signs? Then you can multiply everything together under the same radical. As long as they have the same root, and they will for what you're doing now. So we're going to multiply everything together. So go ahead and do that real quickly. Let's record. Oops. 2x, fifth root of x squared, all over y, and this is y to the 1/5 next to it. So when you have to rationalize the radical, make them fractional exponents. So now you're going to multiply by y to some power. Who said that? All right, cool. You guys are so smart. These guys are over here struggling to stay above water here because they haven't been here. 1/5 plus what? Makes 1. 4/5. I can't tell by your faces. You look frustrated. So if you got it, nod your head, be like, okay, we got that. Okay, we can go on. All right. So we're going to put 4/5 here. So what do you have on the bottom then? So these two go together to make y to the first, and you already have a y to the first there, so that's y squared. Two x and the fifth root of x squared y to the 4th. Y to the 4/5 is the fifth root of y to the 4th. Now you are done.
Wait, but hold on, can you take the y to the fourth and y to the second out? Because they're both the same.
X squared and y to the 4th. No, that's x squared, not y squared.
I mean y to the second and y
On
to
the bottom?
Yeah.
Y to the second is already on the outside of the radical.
Oh, so is it just 2x of y squared times 5
the fifth root of x squared y to the fourth.
Oh, maybe similar deal one same thing.
Yeah, these are tough. Want to see another one?
So just keep going down the list.
73? We got. Did you finish it?
What's that?
Yeah.
Should be yeah.
That's the first part.
You know that sounds dark, menacing, and you simplify
That's the first step. But you can't have radical denominator. That's the next step. So the first step gets you to the point where you need to rationalize your denominator. So this is 8 to the 1/5, right?
Yeah.
So we multiply by 8 to the 4/5 to make this 8 to the 1st. Which is that right there, right? You got to multiply by 8 to the 4/5 on top.
Oh.
So this is the 5th root of 8 to the 4th. So all I did was put the 8 to the 4th inside the 5th root.
So it's just 8 to the 4, not 8 to the 4/5.
Well, it is 8 to the 4/5 because the root would go underneath each one of these exponents. Okay? Guys, these are the hardest problems so far. Well, I mean, in what you're doing for the quiz. Now, you guys are asking the most difficult problems. Alright? There'll be a few easy problems on the quiz.
So how many of them are going to be the difficult ones? Majority or less?
There's probably 2
Out
that
of
are.
100%?
There's at least one that's like these.
Gotcha.
Okay?
How many problems are there on the quiz?
10.
It's not that many.
We have time to do them.
So let's take a look. Let me pick a few. Okay. Do you want me to just ignore 1.1 for now because you guys feel good about it?
Yeah, 1.1's easy.
Two minutes to do as much of that as you can. So let's take 4 times 5 is 20. A squared times A squared is A to the 4th. B times B is B squared.
So I have a question for you. I simplified both of them before I...
There's multiple ways to do it.
Okay, I was just making sure that was right.
And that's what we've been saying all along. Let's simplify what's in each one first, and it makes it easier later. Just I saw somebody do it this way, so I thought I'd do it this way. And then you have A cubed and B to the 6th. And now you can simplify here. That's 10. 3 of those reduce with 3 of those, leaving A to the 1st. 2 of those will reduce with 2 of those, leaving B to the 4th on the bottom.
No, and B's not on because it's a negative if you put on.
Yeah, if you did the subtraction, it'd be B to the negative 4 at the top. Then you'd have to move it.
We have time for at least one more problem, I think.
We got enough time for quite a few. All right, next. Let's do number. So it's 54b. Of course, I don't know if I've done this already. 4 plus x to the 3 halves. I think I did this already, but